Hi everyone, in this video we're going to do a little practice so that you can see what I expect you to be able to do given special values information. So I can again either give you information about an angle that we would consider a special value, or I could give you information about the x or y coordinates, and you should be able to work backwards and get some other stuff from that. So the first one, once our x and y coordinates, if we are on the unit circle and we have an arc length of 4 pi over 3 and then also 11 pi over 6. Okay, so one thing that I expect you to be able to do, I already know that purple pen's about done, is just count out your pi over 3s or pi over 6s or pi over 4s and figure out fairly accurate location on the unit circle. So pi over 3s, we know that pi is halfway around, so we're going thirds of pi. So 1, 2, 3 pi over 3, and then we need one more. So down here is going to be our location. So there's a point that is at the end of an arc length of 4 pi over 3. And we would like to be able to find the x and y coordinates of that point. Your goal is to have the first quadrant memorized. So what we should know is that at the end of the arc length 2 pi over 3, this little one right here, is the point 1/2 root 3 over 2. So your job is just to memorize these things. And I'll be either in class if you're in a face-to-face class or posting online special values quizzes that you should be trying to take without your calculator to test yourself and see if you really do have enough memorized or not. Okay, so if this is 1/2 root 3 over 2, this one is straight across through the origin, so you have to flip, and you should get coordinates -1/2, negative root 3 over 2. That 3 does not look much like a 3. -1/2, negative root 3 over 2. So that was for 4 pi over 3. If we want to do 11 pi over 6, so 11 pi over 6, let's see, all the way around is 2 pi, which is equal to 12 pi over 6. So we are a single pi over 6 short of that. So you can try and count out all 11 of them if you want, but sometimes working your way backwards is a little easier. So this is positive 1 pi over 6. This is negative 1 pi over 6, which is coterminal with 11 pi over 6. So 11 pi over 6. So it's pretty darn close. Mine's kind of looking close to the middle. It's a little closer to the x-axis. Okay, so for 11 pi over 6, let's see. So like I said, pi over 6 is straight across through the x-axis. And that one, again, you just have to work on memorizing this. Arc length pi over 6 lands at the point with x coordinate root 3 over 2, y coordinate 1/2. If 11 pi over 6 is directly below that, then we should have same x coordinate, root 3 over 2, opposite y coordinate, -1/2. Okay, so this is the beginnings of it. And then there's another step that I want you to be able to deal with after this. So given an arc length, you should be able to figure out where you are on the unit circle, and you should be able to tell me your x or your y value. If you can do that, you should be able to tell me the values of any of the trig functions. So next one here gets into that. And this is what the special values quizzes are all about. Just, can I ask you any trig function of any multiple of pi over 3, pi over 4, pi over 6, pi over 2, so on. Okay. So I personally draw myself a little unit circle for every single one of these. So if I want a 7 pi over 6, okay, so we want to be thinking in pi over 6s, which means all the way around is 12 of them, just like the last time. Halfway around is 6 pi over 6. And we want to go 7 pi over 6. So pi over 6 is fairly little. It's a third of the way through one quadrant. So if we want to go 7 pi over 6, we're going to go to pi over 6, and then we're going to go one more, which will put us right down here. This point has coordinates. Let's see, if this is our pi over 6, I didn't leave myself good room here. This has coordinates root 3 over 2, 1/2. So the point we're ending up at has coordinates negative root 3 over 2, -1/2. We were asked for cosine, so we really only want the x values, so our answer is going to be a negative root 3 over 2. Okay, so this is our big goal. Again, I want to be able to ask you to evaluate any of our trig functions at any multiple of pi over 4, pi over 6, pi over 3, pi over 2, pi, so on. Okay, 17 pi over 6s. All right, we're already on this pi over 6 kick, so let's go for this. 17 pi over 6s, that's more than once around. We've already said that 12 pi over 6 is the same as 2 pi, so 12 pi over 6 would land you right here. 6 pi over 6s is halfway around, so 12 and 6 is 18 pi over 6s. And we only wanted 17, so we want to stop 1 pi over 6 before that. So pi over 6 is this long. We want to stop a single pi over 6 before we get to 18. So we've gone all the way around once, and then not quite halfway around after that. Okay, so again, we want to be using as kind of our reference point the one at pi over 6, which has coordinates root 3 over 2, 1/2. Memorize, memorize, memorize. If we are straight across, then our point is going to be negative root 3 over 2. I said negative, there we go, 1/2. This question was just asking for a y coordinate, so I'm just going to say 1/2. It is really important that you give me the piece of information I'm asking for. Sometimes people will write down the coordinates of the point, and that's great, but I want you to look at that question and understand that I'm saying, can you tell me your y coordinate if you're at the end of an arc length 17 pi over 6? So if you don't recognize the y coordinate part of it, you don't understand the trig function part of it. So that's not good. Okay, next, cosine negative 5 pi over 2. Okay, so let's see. Negative 5 pi over 2. So pi over 2 is a quarter of the way around the circle. Negative means we start at 1, 0, and we head down. So here's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and 5 pi over 2. So we're at the bottom of the circle, which the pi over 2s are nice and easy. I don't think we need much memorizing. The bottom of the circle is 0, negative 1. And we're looking for cosine of negative 5 pi over 2. So this is saying step 1, figure out where you are. Go around negative 5 pi over 2. Step 2, tell me your x coordinate. So my x coordinate is 0. Okay, tangent of negative 5 pi over 3. So pi over 3s, 1, 2, 3 pi over 3. 4, 5. Okay, so we're going to go backwards 5 pi over 3, and we're going to land right here. This is our point. 6 pi over 3 would be all the way around, so 5 pi over 3 is not quite all the way, and again, the negative gives us that opposite direction. So actually, negative 5 pi over 3 is coterminal with pi over 3. So this is exactly the same location if we just went pi over 3 in the positive direction, which means we have coordinates 1/2. This time we're towards the top of the circle, so x is smaller, 1/2 root 3 over 2. We're looking for tangent, so we want to take sine over cosine, so root 3 over 2 divided by 1/2 is the same as multiplying by 2, and it looks like at this point the value of tangent is root 3. I know instructors who want people to memorize values of tangent as well. I don't do that. I figure if you can remember your x and y coordinate, you can get tangent very easily. But if you're a good memorizer and you prefer, you could just memorize for all those points that we drew in quadrant 1 in the last video. Memorize sine, cosine, and tangent, and then all you'd ever have to do is flip. Okay, let's see. Couple more on this. Secant of pi over 4. All right, so pi over 4 is right in the middle of the first quadrant. So we know coordinates of that point are 1 over root 2, 1 over root 2. We're looking for secant, which is the reciprocal of x. So if we take our x-coordinate and we flip it, this is why I personally, oh, I shouldn't have circled that. I was circling answers. This is why I personally prefer 1 over root 2 to root 2 over 2, because if we flip this, we get root 2. Okay, this is our actual answer here. If you do the root 2 over 2 and you flip it, you get 2 over root 2, which doesn't look nearly as clear as a plain old square root of 2. Okay. So we need to memorize what our trig functions mean, things like cosine, secant is 1 over cosine, and we need to memorize special values. Cosecant of 9 pi. Okay, so 9 pi, let's see, all the way around is 2 pi. So there's 2, 4, 6, 8, and then one more, 9 pi puts us right here, which is at -1, 0. We're looking for cosecant, which is the reciprocal of sine. So sine is 0, which means cosecant is actually undefined. Okay, one more. Let's see if we can make our purple work for just this one. -11 pi over 4. Okay, so pi over 4 is a quarter of the way through a quadrant. We're going negative pi over 4, -11 pi over 4. That's more than once around. So all the way around is -8 pi over 4. That reduces to -2 pi. And then we want to go 9, 10, 11. So we're right here at this point. And we're right in the middle. So this is going to be a 1 over root 2, 1 over root 2 type point. But they're both going to be negative since we're in that quadrant. So we get -1 over root 2, -1 over root 2. And we're looking for cotangent, which is cosine over sine. Since cosine and sine are equal, it looks like at this point cotangent is just plain old 1. Okay, so this is, I would say, the biggest thing that I want from you. There's other things as well that I think we should be able to do, but that's like the key thing in this section is being able to evaluate the trig functions at the special values. One other thing on here is we don't want to forget that not all angles are special values, right? So this is useful. There are angles that come up regularly, and we can work a lot with trig and get a lot of good understanding just by having a limited set of values that we know. But we don't know all of them, and there's nothing wrong with an angle like pi over 15 radians or 1.8 radians or -0.4 radians. So I don't want to do much here, but just say you can use your calculator to figure out those. There are formulas that help you get some of these from the ones that we already know, so there are tricks, but we can use a calculator for some of these. We're not using calculator on the exams for a while till the end of the quarter, but just to play around with this a little bit and get an idea and be ready to use the calculator when we're solving later on. We can say, so again, make sure you're in radian mode. Radian, so I think I'm good. We can say, what is the cosine? Here, let me move up. So cosine is right smack in the middle here, second row up from the numbers. Cosine of pi, which is second, and then this little caret button, over 15. Okay. And then it will give us an approximate 0.98-ish. So it's approximately 0.98. What does this tell you about your location? This should be telling me my x-coordinate. So what I would like to see is you do this reasonableness check. If you are trying to find cosine of pi over 15, I know that a pi over 6 is roughly here. So a pi over 12 would be half of that. So we're pretty darn close to 1, 0. Which means that our x-coordinate is going to be pretty darn close to 1. So this looks good. So this is a way to kind of check yourself. You can say, okay, this is where I think I am. And then you ask your calculator for cosine or sine, and you can check yourself and see if it matches up with what you were thinking. All right, so sine of 1.8 0.97-ish. I gave you ones with nice big values. We can only get up to 1, so 0.97 is pretty big. Okay, so 1.8, again, I would expect, even without a calculator, that you could give me a ballpark estimate of where you land if your arc length is 1.8. So you should know that halfway around is approximately 3.14, quarter of the way around is approximately 1.57. So if this is 1.57 and we're looking for 1.8, it's just a little bit past that. So this is a little more than 1.5 and a little more than 1.5. And we're looking for out of that 1.5 an additional roughly 0.2. So the top is just shy of 1.6 and we want to go just a little further than that. So it's not going to be very far. It's going to be really close to the top of the circle, which is why we're getting a y-coordinate of 0.97. So what does it tell me? It tells me that the y-coordinate at the end of an arc length of 1.8 is about 0.97. Okay, and then last one, tangent of negative 0.4. So tangent negative 0.4 is about negative 0.42. Okay, so tangent on the unit circle is y over x, which means tangent gives you the slope of a line through the origin and the point at the end of your arc length. So if we go negative 0.4 radians, again, remember this is negative 1.57. So a pi over 6 is kind of close to a negative pi over 6 is kind of close to negative 0.5, which is a third of the way here. And we went negative 0.4, so we're not quite that far. So we're a little bit below the x-axis in quadrant 4. Tangent gives you slope. So this calculator is claiming that the slope of that line is about negative 0.42. That seems reasonable to me. Right smack in the middle of quadrant, the quadrant would be a slope of negative 1. This is definitely looking shallower than that, so a negative 1/2-ish, and negative 0.4 definitely seems like it's in the ballpark of that. All right, thank